When installing recessed lights in existing structures, especially older homes, several factors must be considered. The primary concerns revolve around safely drilling floor joists and ensuring proper grounding of the lighting fixtures, particularly if the original installation did not include grounding. When addressing the drilling of floor joists, firstly, a thorough assessment of the situation is crucial. Begin by determining the joist spacing to estimate the extent of drilling required. This involves measuring the distance between the joists to understand the scope of the work. Secondly, inspect the underside of the joists. Use a flashlight or camera to meticulously check for any existing wires, pipes, or other obstructions on the back side of the joists. This step is vital to prevent accidental damage to existing infrastructure. Consider the possibility of blind drilling. If the joists are spaced far apart and there are no visible obstructions on the backside, blind drilling might be a feasible option. Blind drilling refers to drilling without direct line of sight to the drilling location. If the initial assessment suggests that blind drilling is appropriate, proceed with careful planning and execution. Mark the drilling locations accurately. Utilize a plumb bob to transfer the recessed light locations from the ceiling precisely to the floor above. This ensures that the drilled holes align correctly with the intended light positions. Drill pilot holes initially. Start with small pilot holes to verify the direction and depth of the joists before committing to larger holes. This minimizes the risk of misaligned or angled drilling. Following the pilot holes, drill the larger holes. Use a drill bit that is slightly larger than the electrical conduit or cable that will be run through the joists. This provides sufficient space for the wiring without causing undue friction or stress. If blind drilling presents significant challenges or risks, consider alternative approaches. One option is to open up a small section of the floor. If blind drilling proves impractical or unsafe due to obstructions or unknown conditions, opening a small portion of the bedroom floor above to access the joists directly might be necessary. This provides a clear view and direct access for drilling. Another option is to use a fishing rod or similar tool. If the joists are difficult to access, employ a fishing rod or a flexible wire to guide the electrical conduit or cable through the drilled holes. This method can be particularly useful in tight spaces. Regarding code compliance and grounding, the National Electrical Code (NEC) mandates that all lighting fixtures be properly grounded to ensure electrical safety. This is a fundamental requirement for any electrical installation. When adding a ground to existing fixtures, there are specific guidelines to follow. If the fixture already has a designated ground hole or terminal, and if the fixture has a ground hole but lacks a ground wire, you can add a ground wire and connect it to the green or bare copper wire in the electrical box. This provides a direct path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. However, if the fixture does not have a ground hole, it is generally not permissible to drill a hole in the fixture to create a ground connection. Drilling into the fixture could compromise its structural integrity and safety. Instead, consider using a non-metallic extension box equipped with a ground terminal. This allows you to connect the fixture to the ground wire in the extension box, providing a safe grounding point without altering the original fixture. For cord pendant lights, which often present unique grounding challenges, there are several approaches. Firstly, if the cord pendant does not have a ground wire included in its cord, you can replace the existing cord with a cord that incorporates a ground wire. This ensures that the fixture is properly grounded through the cord. Secondly, if replacing the cord is not feasible due to aesthetic or practical reasons, you can use a ground adapter plug. This adapter will connect the fixture's metal body to the grounding pin of the electrical outlet, providing a grounding path. Here are some additional considerations to ensure a safe and compliant installation. Always turn off the power to the circuit before working on any electrical components. Use appropriate personal protective equipment, including safety glasses and gloves. Inspect all wiring and connections for damage or wear. Ensure that all connections are secure and properly insulated. If you are unsure about any aspect of the installation, consult with a qualified electrician. Following these steps will help ensure a safe and code-compliant installation of recessed lights in older homes. The information presented covers several key aspects of the installation process, including firstly assessing the joists, secondly blind drilling the joists, thirdly code compliance regarding grounding, and finally alternative grounding techniques for older fixtures. Here is a more detailed breakdown of drilling floor joists. Before you even think about drilling, understand the anatomy of a floor. Typically, you'll have finished flooring, then a subfloor, and then the joists, which are the structural members supporting the floor. Wires and pipes often run perpendicular to these joists. First, perform a pre-drilling investigation. Before you even pick up a drill, become an investigator. Gather information about the joist layout and the potential location of existing wiring. How do you do this? Well, firstly, use a stud finder with AC wire detection. These tools can often sense the presence of electrical wiring. However, they aren't foolproof. Secondly, look for clues. Check for existing electrical boxes or plumbing fixtures that might indicate the presence of wires or pipes in the area you plan to drill. Thirdly, use a periscope. This flexible camera can be inserted into small holes to inspect the inside of the joist bay. Now, let's talk about the art of blind drilling. If you can't see what you're drilling into, you're drilling blind. It's risky but sometimes necessary. So firstly, accurate measurements are critical. Measure twice, drill once. Make sure you know the exact location where you want the wire to emerge. Secondly, pilot holes are your friend. Start with a small drill bit to create a pilot hole. This will help guide the larger bit and reduce the risk of wandering. Thirdly, control the depth. Use tape on your drill bit to mark the desired drilling depth. This prevents you from accidentally drilling through the other side of the joist. What about alternatives to drilling? Consider these before you commit to making holes. Firstly, surface-mounted wiring. Instead of running wires through the joists, could you run them along the surface of the wall or ceiling using conduit or wire mold? Secondly, wireless solutions. Could you use wireless lighting controls or sensors to minimize the need for new wiring? Thirdly, existing pathways. Can you use existing pathways like unused ductwork or cable runs to route your new wires? If you've decided drilling is the only option, choose the right tools. Firstly, use an auger bit which is designed for drilling through wood quickly and efficiently. Secondly, use a right-angle drill which allows you to drill in tight spaces. Thirdly, vacuum attachments are helpful. Connect a vacuum to your drill to collect dust and debris as you drill. How should you actually drill? Firstly, slow and steady wins the race. Drill slowly and steadily, allowing the bit to do the work. Secondly, pull back frequently. Clear the bit of wood chips frequently to prevent it from binding. Thirdly, listen and feel. Pay attention to the sound and feel of the drill. If you encounter resistance, stop and investigate. Finally, let's discuss the NEC. The NEC has rules about drilling and notching joists. Generally, you can drill holes near the center of the joist without significantly weakening it, but avoid drilling near the edges. Consult your local building codes for specific requirements. Grounding is a critical safety measure in electrical systems. It provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Let's explore grounding in detail. Understanding grounding. Firstly, what is ground? Ground is a reference point in an electrical system, typically connected to the earth. It provides a low resistance path for fault current. Secondly, why is grounding important? Grounding protects people from electrical shock by providing a path for fault current to flow back to the source, tripping the circuit breaker. It also helps to prevent damage to electrical equipment. Thirdly, grounding vs. bonding. Grounding connects electrical equipment to the earth. Bonding connects different metal parts of the electrical system together to ensure they are at the same electrical potential. Now consider the types of grounding systems. Firstly, equipment grounding conductors, EGs. These are the wires that connect the metal parts of electrical equipment to the grounding system. Secondly, grounding electrode conductors. These are the wires that connect the grounding system to the grounding electrode, which is typically a ground rod or water pipe. Thirdly, grounding electrodes. These are the objects that are used to connect the grounding system to the earth. The NEC outlines the requirements for grounding electrical systems in Article 250. Firstly, grounding is required for most electrical systems. The NEC requires grounding for most electrical systems to protect people from electrical shock. Secondly, the grounding electrode system. The NEC specifies the types of grounding electrodes that are permitted and how they must be installed. Thirdly, equipment grounding. The NEC requires that all metal parts of electrical equipment be grounded. Grounding older fixtures can be tricky because they may not have been designed with grounding in mind. However, there are several ways to safely ground these fixtures. Firstly, check for an existing ground. Some older fixtures may have a ground screw or terminal, even if it's not readily apparent. Secondly, use a grounding adapter. A grounding adapter can be used to connect a two-prong plug to a grounded outlet. However, this only works if the outlet is properly grounded. Thirdly, replace the fixture. If you can't safely ground the existing fixture, consider replacing it with a newer fixture that is designed for grounding. Here are some grounding scenarios and solutions. Scenario 1 is replacing a two-prong receptacle with a three-prong receptacle. If the wiring in the box includes a ground wire, you can simply connect it to the ground terminal on the new receptacle. If there's no ground wire, you can use a self-grounding receptacle, which makes contact with the metal box to establish a ground. Scenario 2 is grounding a metal light fixture in a box without a ground wire. You can run a ground wire from the fixture to a nearby grounded metal water pipe or to a ground rod driven into the earth. Scenario 3 is grounding a subpanel. The subpanel must be grounded to the main panel using a separate ground wire. The neutral and ground buses in the subpanel must be kept separate. Let's consider some common grounding mistakes. Firstly, using the neutral wire as a ground is extremely dangerous. The neutral wire carries current under normal conditions, so it should never be used as a ground. Secondly, failing to properly bond metal parts of the electrical system can create a shock hazard. Thirdly, neglecting to test the grounding system can leave you vulnerable to electrical shock. Testing the grounding system. Use a multimeter or ground tester to verify that the grounding system is working properly. Check the resistance between the ground wire and a known ground point. It should be very low, ideally less than 1 ohm. If you are not comfortable working with electricity, hire a qualified electrician to inspect and test your grounding system. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. Consult your local building codes for any additional requirements. Always follow the manufacturer's instructions when installing electrical equipment. Here are some additional safety tips. Firstly, turn off the power before working on any electrical equipment. Secondly, use insulated tools. Thirdly, wear safety glasses and gloves. Fourthly, don't work on electrical equipment when you're wet or standing in water. Fifthly, if you're not sure what you're doing, hire a qualified electrician. By following these guidelines, you can safely and effectively ground your electrical system and protect yourself from electrical shock. The key is to understand the principles of grounding, follow the NEC requirements, and take the necessary precautions. Always prioritize safety when working with electricity. If you're ever in doubt, consult with a qualified electrician. Remember, electricity is a powerful force that can be dangerous if not handled properly. Grounding is a critical safety measure that should never be overlooked. Now let's consider some more advanced topics related to grounding. Firstly, surge protection. A properly grounded electrical system is essential for surge protection. A surge protector diverts excess voltage to ground, protecting your electronic equipment from damage. Secondly, static electricity. Grounding can also help to prevent static electricity buildup, which can damage sensitive electronic components. Thirdly, lightning protection. A lightning protection system includes grounding rods, conductors, and surge protectors to protect your home from lightning strikes. What about inspecting grounding systems? Regularly inspect your grounding system to ensure that all connections are tight and free of corrosion. Check the grounding electrode for damage or deterioration. Test the resistance of the grounding system to ensure that it is within acceptable limits. Finally, documenting your grounding system. Keep a record of your grounding system, including the location of the grounding electrode, the type of grounding conductors used, and the results of any tests performed. This information can be helpful for future maintenance and troubleshooting. Let's summarize the key points we've covered. Firstly, grounding is a critical safety measure that protects people from electrical shock. Secondly, the NEC outlines the requirements for grounding electrical systems. Thirdly, grounding older fixtures can be tricky, but there are several ways to safely ground them. Fourthly, always prioritize safety when working with electricity. Fifthly, if you're not sure what you're doing, hire a qualified electrician. By following these guidelines, you can ensure that your electrical system is properly grounded and that you're protected from electrical shock. Remember, grounding is not just a code requirement, it's a matter of safety. Don't take shortcuts or cut corners when it comes to grounding. Your life and the lives of others may depend on it. One additional note concerning aluminum wiring, which can be found in older homes. Aluminum wiring expands and contracts more than copper wiring, which can lead to loose connections and overheating. If you have aluminum wiring, it's important to have it inspected by a qualified electrician. They can install special connectors that are designed to prevent these problems. Also, be aware of the presence of asbestos in older homes. Asbestos was commonly used as insulation in the past, and it can be dangerous if it's disturbed. If you suspect that you have asbestos in your home, have it tested by a qualified professional. Do not attempt to remove it yourself. Furthermore, be mindful of lead paint in older homes. Lead paint can be harmful, especially to children. If you have lead paint, take precautions to prevent it from being disturbed. When working in older homes, it's important to be aware of these potential hazards and take the necessary precautions. Safety should always be your top priority. In conclusion, the installation of recessed lighting in older homes requires a careful approach, considering both the structural aspects and the electrical safety. By following the guidelines provided, you can ensure a safe and compliant installation. Here's a checklist before you start. Firstly, have you determined the joist spacing? Secondly, have you inspected the underside of the joist for obstructions? Thirdly, have you considered alternative wiring methods? Fourthly, have you chosen the appropriate drill bit and speed? Fifthly, have you marked the drilling depth on the drill bit? Sixthly, are you aware of the NEC requirements for grounding? Seventhly, have you checked for an existing ground connection in the fixture? Eighthly, do you have a grounding adapter or replacement cord available? Ninthly, are you wearing appropriate safety gear? Tenthly, have you turned off the power to the circuit? By following this checklist, you can minimize the risk of accidents and ensure a successful installation. Remember, electrical work can be dangerous. If you're not comfortable performing the work yourself, hire a qualified electrician. Your safety is worth it. And above all, be patient, take your time, and double-check your work. A well-planned and executed installation will provide years of trouble-free service. This guide provides a comprehensive overview of the key considerations for installing recessed lighting in older homes. By following these guidelines, you can ensure a safe, compliant, and aesthetically pleasing lighting solution for your home.